you have to know the first rule. Are we jotting? The first rule to know that this particular structure, it is ring, it is cyclic, but it is what? The father's name or the giant name for that molecule is phenol, is that the OH must be attaching directly to the benzene structure. How? That is the first rule. Note the OH, which will tell us if something is phenol, must be attached directly to the what? To the benzene. To benzene ring. Meaning, I should have something of this. That is the first rule. Then the OH must be attached directly to this benzene. So this, if they ask you what type of structure is it, forget about being dihydric in nature, monohydric in nature, or trihydric in nature. This is a phenol structure. Why? If someone asks you that, note that this OH is actually attaching to what? Benzene structure. How? But in the case where you have, that is the first rule in naming phenol. In the case you have something of this is a benzene structure, and you have something like this, then the OH is there. You can see automatically, physically, when you neutralize this and this, it is different. The OH attached to this benzene directly. Why this OH attached to this benzene partially? It firstly joined to this carbon before moving to this carbon. It has some kind of stages in Yoruba. OH mwele lekana, omo benzene lekana. But OH okoko gba ipele kan koja to fi wa pele mi. We don't call this one, we don't call it phenol. Why? This OH doesn't attach directly to this. Why this OH attached to what? Directly to it. If you can know these rules, we are good to go in terms of naming this. Are we together? That's first rule. The second rule, guiding how to name phenol. I said the first rule, are we taking it? The OH, you must find a means to identify if a particular aromatic hydrocarbon is phenol through the attachment of the OH to the benzene ring. That's one. The second one is that, note, you must start your counting if you are having so many substituents. The substituent, what I mean by the substituent is that branches, like bromine, chlorine, halogen group. I hope you understand that. I trust you guys. Don't forget to share and also like and please share to the needies. Now note that if what I'm having something of this, I'm having something of this, and the OH is here, and we have bromine here, we have chlorine here, we have what? We have iodine, we have fluorine, and so on and so forth, right? We are having something of this. What should come to your mind is the mistake that we do make is that some people don't start from this. And what makes you to know that this structure is what? Organic, a phenol structure, an aromatic hydrocarbon phenol structure, is as a result of check. Firstly, the first rule that I mentioned is that this OH is attaching directly. Is it attaching directly to the benzene ring? Now, I know, I trust you guys that you are picking that, and I know it will be a correct answer. It is, yes, it is attaching directly to it. This compound is a phenol compound. That is the first rule I mentioned. It's very simple. Rule compound OH, ogudo join, ogudo parapọ̀ mọ́ benzene. Láláìsí nǹkan tó dá wọn láàrin bí mo ṣe draw it. Then the rules, the second rule, which is the most fundamental rule, is that since you have known that this is a phenol, and we only have this phenol, the classification is this is a monohydric phenol, meaning it has one hydroxy group here. You start your counting. This is the substituent. This is the substituent. This is the substituent. Bromine, iodine, chlorine, fluorine. Well, you know, as organic chemistry is concerned, we don't call it bromine. We call it what? Bromo, iodo, chloro, fluoro. These are all substituents, meaning they are the attachments. They are not needed to be there, but they replace the hydrogen that is needed to be there. So we have to call them, that is why in chemistry we call them substituent or what? Branches or attachment. Are we together? So you start your counting from what make you to know that this is phenol, the OH. So you can start your counting from this carbon. I told you that these are Invisible carbon, carbon, carbon. You start your counting from 1, 2, 3, 4,